When it comes to controlling pH in hydroponics, one of the most powerful tools growers use is nitric acid. Nitric acid, or HNO3, is a strong acid and a powerful oxidizer, which means it reacts aggressively and lowers pH very efficiently. Because of this strength, even a very small amount can significantly shift your nutrient solution. But what makes nitric acid especially interesting for hydroponics is this. It doesn't just lower pH, it also feeds your plants. When nitric acid dissociates in water, it releases nitrate ions, NO3-, which are one of the primary nitrogen sources plants use to build amino acids and grow. So every time you adjust pH with nitric acid, you're also adding usable nitrogen nutrition. Why growers use nitric acid? This dual function makes nitric acid a preferred choice in many hydroponic systems. Compared to other acids, it doesn't introduce unwanted elements like excess phosphorus or sulfur. It helps maintain a clean nutrient profile, and it's especially useful during the vegetative stage, when plants need more nitrogen. In fact, nitric acid is often considered the best option for pH control in hydroponics because it adds nitrate, a nutrient that typically doesn't accumulate to harmful levels in balanced systems. Safety and important considerations. It is highly corrosive and dangerous to handle, capable of causing serious chemical burns and reacting with many materials. So always remember, use proper protective gear. Gloves, goggles, ventilation. Always add acid to water, never the other way around. Dose gradually. Hydroponic systems have low buffering capacity, so pH can swing quickly. Also keep in mind, because nitric acid adds nitrate, excessive use can increase your nitrogen levels, which may affect plant balance if not accounted for. Introducing the calculator. To make this process easier, safer, and more precise, you can use a pH down calculator. Let's take a look at how it works. Here we have the calculator interface. On the left, we select the acid type, in this case, nitric acid and its concentration. Here it's 67%. On the right, we enter our water parameters. Current pH, 7.5, target. pH, 5.8. Water volume, 15 liters in alkalinity. For example, 120 parts per million as CaCO3. Once everything is set, we hit Calculate. Result explanation. The calculator shows us exactly how much acid we need. In this case, required nitric acid, 1.77 milliliters. For a reservoir volume of 15 liters, it also shows the nutrient contribution. Because we use nitric acid, the system adds about 26 parts per million of nitrate nitrogen. This is important because now we can adjust our feeding schedule accordingly and avoid overfeeding nitrogen. Practical tip. For best results, always add acid gradually, mix thoroughly, and recheck pH before adding more. Water chemistry, temperature, and buffering capacity can all affect the final result. So treat calculator values as a precise starting point, not an absolute.